Hey guys, welcome back to the channel. In today's video, we're going to continue off with our tech and sentiment scores. Now in the previous tutorial, we calculated all the sent and tech scores for multiple stocks, and we saved all of our workspace in line 179. But in today's tutorial, we're going to use all scores to create a backtest. All scores contain our daily sentiment and tech scores for multiple stocks, and we're going to use this table to run it through an optimization. You can approach this task in multiple ways, but in today's script, I'm going to be talking about subsetting that all scores table to a specific day of the week. We're going to be subsetting our table to Mondays only. The goal of the optimization is to pick a couple of stocks. It'll return a given number, given our limits, along with the number of days that we should hold all the stocks. So we're going to load up all these packages along with our data from this previous script. I am going to be sourcing my database functions, and that's just to return the close price for each of the stocks it picked. But you can ideally change this to fetch the data from Yahoo Finance instead. As I mentioned, we're going to be splitting our data given the day of the week. So ideally, this could be anything from Monday through Friday. We're going to create two functions. The first one is to get the closing price for each of the stocks it picks. So the parameters here is the ticker symbol, which is stock, today's date or the trading day, and the number of days that we should hold. Now, since we do have the closing prices in all scores, but sometimes the price was not available, it's first going to check our all scores table by subsetting all of our data to that specific stock. We're going to calculate the close date, which is in trading days, so it'll exclude holidays and weekends. Now, if the close date surpasses the max date available in our table, we're just going to return NA for the close price, along with the end date, which is the close date it calculated here. Otherwise, if we do have the data for it, it'll subset to that specific close date and return the close price on that date. Now, this is the only place I would use my database to get the close price. So if this pricing is NA, we're going to fetch it from the database. So you would just need to replace line 45 to fetch that information from Yahoo Finance instead. And finally, just return the close price and the close date. Our next function is going to return our trade table. So we need to pass in all of our scores from the previous block. And we're also going to pass in the number of stocks we want to hold in our portfolio along with the hold days. Given our table, we're going to extract the unique number of trading days, and we're going to pass that as a list into this lapply. Now for each of our trading days, it's going to order all of our sent and tech scores from highest to lowest. It'll then subset to the top end stocks you pass in, and for each of those symbols, it'll generate a data frame that contains the stock ticker, the sent and tech score, the start and close date, the start and end price, the number of points, so the end price minus the start price, the percentage return, the number of fractional shares we would have bought had we allocated $100 to each of the stocks, and our dollar return. Once it does that for all of the stocks, we're going to combine that as a single data frame and return that table. Once we have done that for all of our dates, we're going to combine that as a single data frame as well. We're going to reorder by start date. We're going to add our equity curve and return that as a data frame. So those are our two main functions. Now in our next block, we need to set our optimization parameters. By using our trade table function, we're going to pass in our table, and will be a vector of two integers. The first will be for the number of stocks, and the second will be for the number of hold days. Now, if there was no error in the function, we're going to omit any NAs, and that's for the stocks that it picked at the very last date, which would be technically pending trades. Next, we're going to get the percentage return each day, so we're going to pass in that data frame. We're going to group by end date. So given our basket of stocks each day, we're going to calculate our average return using the dollar return column. We're going to convert that into an XTS object, and our optimization value will just be the average return of our portfolio divided by the max drawdown, and that's what we will be optimizing for. Ideally, we won't see a large drawdown in our results. Otherwise, if line 115 created an error, our optimization value will be set to 100. Since the optimization seeks to minimize, we're going to set line 127 to a really large number, and that's why I flipped the sign in line 125. We also need to set our lower and upper limits. So for the number of stocks, I want to choose anything from 2 to 20, and for the whole days, I'm going to be using a number between 2 and 9. We also need a function to round our lower and upper limits to whole numbers, since we can have fractional number of stocks and whole days. To accommodate for that, we're going to be using the function in line 136. Now we can run our optimization using optim. We're going to pass in our optimization function, our lower and upper limits. For our control list, we're going to set the iter max to 10, but I recommend you setting this number to something like 100. Whatever number you pick here is the maximum number of iterations iterations it'll go through. And finally, we just need to insert our FN map or our rounding function. Once it's done running, we're going to save our output as an RDS file. We're going to be saving that as a backup so we don't have to rerun our optimization each time. For each iteration that you see here, it has printed out the optimization value. So in this case, it's the inverse of our average portfolio return over our max drawdown. It's also going to print out the best parameters it found. So for the most part, it picked the top 2 ranking stocks and it wanted us to hold it for 2 trading days. But as you see in line 9, it found a higher optimization value, having 20 stocks and holding for 9 trading days. That's why I recommend you setting the itermax to something like 100, as it does take a while to truly find the best parameters. But say that this was our best combination, we're going to extract our results from Optim in the next block, and that's done in line 154. We're going to pass in those values to generate our trade table. And if we take a look at all trades, so for each of our trading days, it's going to pick our top 20 stocks, given our cent and tech score. The first 20 observations will have the same start date. We're going to hold for 9 trading days. Here we have our start and end price, the number of points for each of the stocks, along with the percentage return, the number of fractional shares had we bought $100 worth of each stock, the dollar return, and our equity curve. So since we have a basket of 20 stocks, we would need approximately $2,000 if we're able to trade fractional shares. So that's why I'm also using the day of the week, since there's a lot of turnover going on. Let's take a look at our equity curve had we traded this model. So here in the next block, we're going to use chart series. We're going to convert our equity curve into an XCS object and order by the end date. Now from January 22nd to November 22nd, our equity grew by approximately $850. Now since we're allocating $100 for each of the stocks, we will need to have a portfolio size of at least $2,000. Now if we divide the 850 by 2,000 needed each rebalancing period, our portfolio return would be about 40%. But let's see how that compares to the benchmark. Now in the next block, we're going to read in SPY and use that as our benchmark. We're going to get our portfolio return for each of our rebalancing periods. We're going to convert our portfolio returns to an XTS object and merge it with SPY. And we're going to plot the performance of this portfolio against our benchmark. So we do see that our portfolio ended somewhere around 40%, which outperformed the benchmark. Now we need to see how well this performs at a sample, and I would recommend you check other days of the week. So I would rerun this optimization to see if we get better results using a different day of the week. And given those results, we can monitor how well this performs at a sample. But with that, guys, this concludes the video. I hope this was useful information. I'll go ahead and leave a link down in the description area to my Patreon where you can find this script. Please consider subscribing to the channel if you haven't done so already. Thank you so much for watching, and I'll see you guys in the next video.